Okay, so we're going to begin by first looking at the paper that you guys were given yesterday. It was the word problems number 2. We're going to start with number 5 and then we'll also do number 6. Mr. Britz also has the answers written up on the board for you as well, so please be sure you're looking at that. Before we begin though, I want to talk about what I noticed when I was going through the papers tonight grading them. There's a big difference between not understanding and not putting in the effort. So some of you, I think, are claiming that you don't understand it, but I'm not sure that you're putting in 110% effort. So let's begin the 110% effort right now while you're going through today's class, watching these videos, so we can hopefully have some success on Monday and Tuesday whenever you're quizzing. So number 5, let's begin with that. Find 3 consecutive positive odd integers such that the sum of the squares of the 2 smaller numbers is 9 more than the square of the largest number. So first let's determine what our unknowns are. So we have to find 3 consecutive positive odd integers. So I have the first, I have the second, and I have the third. So for the first integer, obviously I have no idea what it is, so I'm going to assign that to be x. Now, in order for it to be consecutive, that means it has to be right in next, or right in a row. It also has to be positive and odd. So if you just think of consecutive positive odd numbers, let's say 13 and 15. If 13 was the first number, in order to get to the next positive odd number, I add 2. That's how we're going to represent the second one. It is x plus 2. As long as your first number that you're starting with is a positive odd number, if you add 2 to it, you'll still get another positive odd number. So let's think about how we're going to represent the third one then. So to get to the next odd number, I would add 2 to this one, or 4 to the original. Either way, it's going to be represented as x plus 4. So we have what we're going to represent our 3 unknowns as. So we've taken care of everything up until this point in the problem. Okay. So now we need to look for some key words here. We're going to be finding the sum. Well, by this point in the ballgame, I hope you know that the sum means that we're going to be adding. So now we need to figure out, okay, what are we going to add? Well, it says the squares, not the square root, the square of the 2 smaller numbers. So go look over here. The smallest number is x. So it said the square of that, so that is x squared. Then it said to do the square of the next smaller number. So we have x plus 2 here. So the square of that is x plus 2 in parentheses squared. Then if we continue up here, we have the keyword is. Please circle that. The word is means equal, like it always has. So is equals 9 more than, oops, sorry. Okay, minor glitch, sorry. So is, we said, is equals 9 more than, so I'm going to be adding 9 to the square of the largest number. So our largest number is x plus 4, and that's being squared. Okay, so we have our equation set up. So what we need to do now is we need to simplify. So x squared, there's nothing more that we can do with that. X plus 2 squared is the same as x plus 2 times x plus 2. X plus 4 squared is the same as x plus 4 times x plus 4, plus there's the 9. So we still have some simplifying to do here. So when I multiply this out, x squared plus 2x plus 2x plus 4. And then I have some simplifying over here that I'm going to do as well. So I get x squared plus 4x plus 4x plus 16 plus 9. Okay, on each side of the equation, let's first go and combine our like terms. X squared plus x squared, those are like terms, so we add the coefficients. 1 and 1 gives me the 2. The like term part of it stays the same, so it stays x squared. 2x plus 2x is 4x. I still have the plus 4. And again over here we have some like terms, so there's our x squared plus 8x plus 25. Now keep in mind here we have this equal sign, so we have to solve. So in order to solve it, we need to get this equal to 0 before we can start to factor it. So I'm going to subtract x squared from both sides, and I get x squared. Then I'm going to subtract 8x from both sides and get negative 4x. Then I am going to subtract 25 from both sides and get negative 21. All right, so what I need to do then, I'm going to do regrouping. So for the regrouping then, I'm going to do x squared minus 7x plus 3x minus 21. I'm running out of room here. So I'm going to regroup. In the first parenthesis, we'll go up here with it, take an x out, so I'm left with x minus 7. Here I can take out a 3, and I'm left with x minus 7 again. This is equal to 0. So I have x minus 7 times x plus 3 equals 0. So when I go and solve this, I need to show x minus 7 could equal 0, or x plus 3 could equal 0. So I get x equals 7 and x equals negative 3. So let's not jump to conclusions and assume that those are both of the answers. If we go back and look at the problem, it said it has to be positive and it has to be odd. So if I look at negative 3, clearly that's not a positive one, so that's not an option. So the only one that I can use here is the x equals 7. But it also told me that I needed to find all 3 of them. So I need to go back up here and I need to figure out what the first, the second, and the third is. So the first is x. Well, obviously that's 7. The second one is x plus 2, which is 7 plus 2, which is 9. So I have 7, I have 9, and then the last one is 7 plus 4, which is 11. So my solution here would be 7, 9, and 11, and there would be no labels needed there because we're just talking about numbers. So take a minute. If Mr. Britz needs to pause this, that's fine. And go through and look and see if you have any questions on that problem. Okay, let's move on then to look at number 6. So it says the length of a rectangle is 7 units more than its width. If the width is doubled and the length is increased by 2, the area is increased by 42 square units. Find the dimensions of the original rectangle. So really what we're talking about here is two different rectangles. So let's just draw out two rectangles so we can see them. This visual will definitely help you. So for the original one, which is just going to be my top one, it says the length of a rectangle is 7 units more than its width. I don't know what the width is, so I'm going to use the logical variable of W. It says the length is 7 units more. So the length is W plus 7. Notice how we're keeping it all in terms of the same variable. Then it says if the width is doubled, so now we're talking about this one down here. So if I double this width, if I double anything, I multiply it by 2. So that becomes 2W. And then it says the length is increased by 2. So if I go up here and look at this length, it would be W plus 7, but then that's increased by 2. So really, it is W plus 9. If we go back and look at that, it says that when we do that, the area is increased by 42 square units. So what I need to do is first find the area of the original one. So I do length times width. And then when I go, it says that it is 42 square units larger. So it's going to be 42 larger than this one down here, which would be 2W times W plus 9. So take a second. If you need Mr. Britz to pause this, ask him to do so, and think about where that equation came from. Again, this diagram over here is what's going to help you. So let's go and let's start simplifying. So I get W squared plus 7W plus 42. And over here, I simplify that to get 2W squared plus 18W. So what I need to do now is I need to get it equal to 0. I'm going to move everything to the right because I like my first term to be positive. So I subtract the W squared and I get W squared. Subtract the 7W and I get the 11W. And then I'm going to subtract 42 minus 42. And that is equal to 0. So whatever method you use, I'm not going to take the time to show those, you would end up with the factored form of being W plus 14 times W minus 3. So when I set each part equal to 0, you'll notice that I get a width here of negative 14 and a width here of 3. Well, I cannot use or have a negative width. So this one we automatically cannot use. So it wanted the dimensions of the original rectangle, which means we need to go up here to this one. So we already have the width. So the width is 3, and let's find our unit of measurement. No units given, so we'll just write units. And the length is over here, and it's W plus 7. So 3 plus 7 would be 10 units. So 3 units and 10 units would be our actual measurements of the original rectangle. Take a second again. Let all this sink in and see if you have any questions. If you do, please be sure to ask.